Structuring the model. Any model in at risk should agree in general to the following step-by-step process. The first requirement is to have a deterministic model. In our terms, a model is a simplified interpretation of a reality expressed, in this case, through mathematical relationships, linking input variables to output results. In other words, having a model implies having defined how input variables interact between each other under a mathematical framework in order to create one or more output variables that should be analyzed. In our example, the model consists on all the mathematical relationships that calculate revenues, expenses, and profits for each one of the 12 months and their totals, based on elemental data such as number of contracts, price per hour, fixed and variable expenses, and others. At first, this model can be structured as a deterministic one. In fact, step 2, which consists on inserting distribution functions, converts this deterministic model into a probabilistic one. A deterministic model is essentially a formula. If you always start with condition A and condition B, you will always get result C every single time. Number 2, therefore, when we insert at-risk distribution functions replacing the key variables of the model, we are transforming it from a deterministic one into a probabilistic one. Stochastic models incorporate one or more probabilistic elements into the model, expressed as distribution functions, which means that the final output of the model will typically be some kind of confidence interval with the most likely point estimate. For example, when we consider the hourly labor expenses as a range and not as a single point and fixed estimate, we are creating a stochastic or probabilistic model based on potential variations of these expenses. All key variables will be considered probabilistically as ranges, therefore creating a model that will fully express as a stochastic one. Number 3, the final output or outputs of a model is what you define on step number 3. These are the key results of our calculations that we want to focus on after a simulation is performed. In our example, the main focus Joe wants to analyze is the total amount of net profit he is able to generate for the year on cell N24. Therefore, this cell, at least, should be declared as an output for the model. Any other cell in the model could also be declared as an output. For example, Joe might be interested in analyzing the probability of not breaking even on winter months. In order to make such calculations after the eventual simulation is executed, you need to previously declare those profit cells as at-risk output variables. Number 4, if input variables have strong direct or inverted relationships to each other, it is important to include this optional yet dramatically relevant element on your model: correlations. In many situations, it is important to account for correlation between input variables. Correlation occurs when 2 or more input distributions are related. For example, it might be known that when one input is relatively high, a second input also tends to be relatively high. A correlation coefficient is a numerical measure of some type of correlation, meaning a statistical relationship between two variables. A very strong correlation coefficient of 0.99 between two variables would look like this. A mildly strong correlation coefficient of 0.80 would look like this. A mild correlation of 0.4 between two variables might look like this. Number 5, defining configuration settings allows the user to specify how the Monte Carlo simulation process is going to be run and controlled. Number 6, the core of the whole process consists on executing or running the Monte Carlo simulation. At this step, at-risk simulates thousands of probable outcomes based on the estimated statistical distributions of each variable on the model. Simulating means generating random numbers along the curve that has been previously defined for each input variable on the model, and recollecting the iterated and recalculated results on each one of the previously defined outputs of the model. In other words, the Monte Carlo simulation process run by at-risk calculates results over and over, each time using a different set of random values from the probability definitions defined for the input variables. Depending on the number of uncertainties and the ranges specified for them, a Monte Carlo simulation could involve thousands or tens of thousands of recalculations before it is complete. Monte Carlo simulation produces distributions of possible outcomes, values for the output variables. At risk, number 7, offers an array of different charts and reports to summarize and easily interpret the outcomes of output variables after a simulation is performed. By taking a look at the different charts and reports, the decision maker in this case is able to answer questions such as the following. What is the range of possible outcomes of potential profits? What is the probability of achieving a certain level of profitability under different conditions? What are the key input variables that have the most impact driving profit, risk, or variation? Number 8, immediately after charts and reports are generated, the need to make sense of them with adequate interpretation arises. For example, a specific type of chart that the software generates is a tornado chart. In general, tornadoes are charts that depict the relative strength of input variables upon output variables. It turns out that at risk contains at least 5 different types of tornadoes, each one with a different interpretation. 9. When presenting results, we certainly not recommend getting into a deep level of detail with respect to the Monte Carlo simulation, as it may become pretty technical. You could risk spend a lot of time on technicalities while missing the presentation of important points. First, state your problem to be addressed. Then, summarize what type of analysis was performed to address the problem. Quickly jump to show the key result variables and how decisions shall be made depending upon the outcome of the risk assessment and other factors. We just recommend showing the chart of the bottom line result distributions, a tornado chart that identifies key risks in the analysis, and perhaps charts on the key risk variables. After that, you should be able to jump onto recommendations and conclusions.